Good morning or good afternoon, whenever you're watching this video. We are going to do Tuesday on our DMR for number 27 together. So hopefully you've already done it. If you have not, you can do the video right along with me, and we will start with number 1. It says, what is the mode and the range for our data set? Now, if you remember, I've always required you to do one thing before you find the mean, the median, the mode, or the range. Do you know what that is? Yes, you guessed it. We need to put our numbers in order from least to greatest. So, looking at the data set, it looks like the 8 is our smallest number, and it occurs 3 times. So I'm going to use this space here at the bottom to record my numbers. Okay. The next largest number in the data set looks to be 13, and I see it twice. I see 14. I see 19. I see 23, and I see 25. Okay, I want you to look at what Ms. Conley did. This organizational piece is helpful because when we're finding the mode, remember the mode is the one that you see most often. I bet you can see it easily now. Which one occurs more times than any of the other numbers in your data set? I see 8, 3 times. 1, 2, 3. And everything else either occurs twice or only once. So 8 must be our mode. Do you see how putting your numbers in order from least to greatest was helpful? Okay, now let's look for the range. The range is the difference between the largest number in your data set and the smallest number in your data set. Now, if you did not put your numbers in order from least to greatest, you might see the number 8 and then the number 8, and then your range might be 0 because these numbers are not in order. But when we put our numbers in order, we can get an accurate range. So we are going to take 8 away from 25. Now, I'm going to show you what I'm thinking in my head instead of regrouping. I know that 8 could be made with 5 plus 3. Okay? So I'm going to do 25 take away the 5, which gives me 20, and then 20 take away the 3, which gives me 17. I didn't do any regrouping. I just used some math strategies to help me get to 17. Now, I can also check this with the inverse operation. That means I can add 8 to 17 and make sure I get 25 to make sure I'm right. You can even use your fingers. I'm okay if you use your fingers. So 17, 18, 19, 20, 21, 22, 23, 24, 25. So if I count up 17 plus 8, I do get 25, and I'm correct. All right, let's look at number 2. 2 is an elapsed time problem. It says Tom has a meeting that begins at 6:13 p.m. He lives 8 hours and 23 minutes from the main office. What time does Tom need to leave his house to be at the meeting on time? Okay. Now, this problem to me is a little silly because if you live 8 hours and 23 minutes from your work, maybe you should find a new job that would be closer to home. But we don't know what kind of meeting Tom really has to be in attendance for. So we're just going to go with it. When we use elapsed time, we're going to use our number line strategy. So I want to see a number line on your paper. You can see I've already worked it out back here, so I'm not going to give you any answers yet. And it says his meeting starts at 6:13 p.m., but he lives some distance away, and we need to know what time he leaves his house. Now, the word begin here might trick you to think that you need to put 6:13 p.m. at the beginning of your number line, but it actually needs to go at the end of your number line because that's the time the meeting is going to begin, and he has time that he needs to travel, and we need to figure out what time does he need to leave. So we are actually finding the start time on our number line. They gave us the elapsed time of 8 hours and 23 minutes. So let's use 8 hours and 23 minutes to find the start time. You probably already noticed that we are going to have to go back in time. So let's start with, I know my elapsed time needs to be 8 hours and 23 minutes. Okay, so let's start with the hours, okay? I'm not going to jump all 8 hours at one setting. I am going to chunk it. I'm going to do 6 hours first because 6:13 take away 6 hours puts me at 12:13 p.m. I like the 12 o'clock benchmark because that's the point where I have just gone into PM time. So as I go back, I know after I get, if I go before 12 o'clock, I'm going to go into the morning. So I'm going to try to make that friendly benchmark, okay? Now I've jumped 6 hours out of the 8 hours. So I'm going to jump the other 2 because 6 plus 2 is 8. And 12:13 p.m., 12 take away the 2 hours is going to get me at 10:13. And now it is a.m. So that's what I was talking about. When you move over the 12 o'clock mark, you're going into the afternoon. Or since we're going back in time, we're going back into the morning. Okay. Notice that Miss Conley used the mountain for her hours. I'll use the hills over here for my minutes later. And I documented the time as I'm jumping back so that when I get to my question mark, I should have a time where he should leave. So I've completed the 8 hours. Now I need to do the 23 minutes. I'm not going to jump all 23 minutes in one jump. I think that would be really messy mathematically. So I'm going to take 10 minutes. I'm going to do a little hill, and I'm going to jump 10 minutes from the 23. So I know that will leave me with 13 minutes left to jump. Okay, 10:13 a.m., take away 10 minutes. It's going to bring me to 10:03 a.m. Okay, and then in order to comfortably make the next hour, I'm going to jump 3 minutes. So now I'm at 10 a.m. Okay, so I jumped those 3 minutes. That means I only have 10 minutes left. I think we can do the final jump of 10 minutes. So 10 a.m., take away 10 minutes, puts me at 9:50 a.m. So Tom needs to leave his house at 9:50 a.m. in order to get to his meeting on time. I hope that made sense. Check your number line, make sure it matches mine. All right, let's go into number 3. So Sue is making cookies for her Girl Scout troop. She made 10 batches, and each batch she used 3/5 of a cup of sugar. How many cups of sugar did she use in all? It looks like she's going to use 3/5 10 times. We can set that up mathematically, and we can use a picture. So mathematically, she used 3/5 10 times. Notice I said that word times. So we are going to multiply 3/5 10 times. You could also do repeated addition if you want to add 3/5 and 3/5 10 times. But remember in yesterday's DMR, I talked to you about using multiplication as a faster strategy and a more efficient strategy as a 5th grader than repeated addition. Okay, so let's just do the math first, and then I'll show you in the picture. So 10 whole batches can be written 10 over 1. So 10 one-whole batches of cookies. And I'm going to use 3/5 for each one. So when we multiply fractions, we just multiply straight across. 10 times 3 is 30. 1 times 5 is 5. So you get this lovely improper fraction. But I want you to remember that your fraction bar is division. You can put your hands in the air and use our movement strategy when we try to model 30 divided by 5. What is 30 divided by 5? Did you say 6? You are right. That means Sue needs 6 cups of sugar. Okay? This is actually a strategy that you and your parents and any of your family members who are cooking have probably used a fraction of a cup. Now let me show you how you can do this using this model. We are going to shade 3/5 10 times, and we should end up with 6 whole cups shaded in. Now in order to do that, you're going to shade 1, 2, 3/5. So that should symbolize the first batch. And then I'm going to shade 3/5 again until I get to 10 whole batches. Now, I am not going to shade 3/5 on a new bar. I'm going to continue creating whole cups until I've done my 10 batches. So let me show you what I mean by that. So I have 3/5 here. I'm going to keep doing 3/5. 1, 2, 3/5 here. That's my second batch. Notice I'm filling in a whole cup before I move on. And another 3/5. And another. The 4th batch. And another. That's the 5th batch. And another. It's the 6th batch, 7th batch. Okay, and I'm just keeping track of my batches as I go along. 1, 2, 3, 8. 1, 2, 3, 9. 1, 2, 3, 10 whole batches. So if you notice, I have 1, 2, 3, 4, 5, 6 whole cup shaded. It matches. Great job, guys. Remember, I'm okay if you use the math strategy or the picture strategy. They both work. Okay. All right, awesome. Let's move on to number 4. Number 4 says Sandy is baking cookies. She has baked 498 cookies. She then splits them between 13 of her friends. How many cookies does she have left? Now, you're probably thinking, this is a word problem. I can use a calculator. You're right, you can. So let's look at it together. She's baking cookies and she splits them. Do you know what operation would require you to split or share things? Did you say division? You're right. We can and we will divide in this problem. We need to divide our cookies to 13 of her friends. Okay, so if you use the calculator, I want to show you something for a second. So if you take 498 cookies and you divide them by 13 of her friends, you get 38 cookies and this long decimal. Okay, now it says, how many does she have left? Well, it looks like the friends are going to get 38 cookies and then this fraction and decimal is here. Does that tell me how many cookies that she has left over? When I'm looking at the repeated, or not repeating decimal, but when I'm looking at the decimal, it's going on and on and on forever. To me, I can't understand how many she has left. So this should be a note to you that if you get an answer like this and it doesn't tell you how many she has left, then you are going to have to do the division out on paper. Okay? Don't be scared. Remember, I've showed you how to do it. So we can do 498 and we are going to divide it by 13. Okay? Miss Connolly prefers the traditional algorithm when dividing. So we're going to go digit by digit. Can 13 go into 4? No. So you can put a 0 up here or an X. Okay. Can 13 go into 49? Yes. But we need to figure out how many times. And we need to use our multiples of 13. So a strategy you can use is listing your multiples down the side. So 13 times 1 is 13. 13 times 2 is 26. 13 times 3 is 39. And if you want to use your calculator since you're doing at-home learning to find your multiples, go ahead. If you notice, Miss Connolly is doing, so I would do 13 times 4, get 52. Okay, and I'm going to go ahead and stop right here. I'm stopping because 13 times 1, 2, 3, 4 gets me 52. And I need to get to 49. This is too big, so I must use the multiple of 3. 13 times 3 is 39. So 49 take away 39 is 10. And then I'm going to bring down the next number. Okay. Now, 13 times 4 is 52, but I'm trying to get to 108. So you need to keep listing your multiples. So let's do 13 times 5. 13 times 6. 13 times 7. And 13 times 8. And 13 times 9 is 117. Okay, I'm going to stop there because remember my goal number is 108. And if I come down to the multiple of 1, 2, 3, 4, 5, 6, 7, 8, I get enough. If I do 9, I'm over 108. So I'm going to use 8. I'm going to subtract my multiple of 8. And then I'm going to get this. Okay, I want to look at something with you. When you originally used your calculator and you did 498 divided by 13, you got 38 and this decimal. This should let you know that there is a remainder. When you divided, it looks like each friend gets 38 cookies and then something is left over. Okay, this should symbolize that there's a leftover. But you just can't represent your leftover as a decimal in this word problem. So I knew when I was doing my division that my goal number was going to be 38 up here. I knew that. But I had to do the division out on paper in order to actually get the remainder. So it looks like when she divided 498 cookies up to her 13 friends, that each friend got 38 cookies, because we're dividing cookies, and then we had some cookies left over. Now, when I do the division out on paper, I see that I have 4 cookies left over. When I do the division in the calculator, it doesn't show me 4 cookies as a remainder. It shows it as a decimal. So when you do your division, sometimes you have to do it out on paper. Okay, I want you to look at what I did. Okay, perfect. Really proud of you for doing that problem with me. I know that sometimes division can be tricky. All right, let's work on the last problem together. It says, the chart below shows the number of pages that Sue read in her book each day last week. So Sue's reading. Day 1, she reads 8 3/5 of pages, and so forth. How many pages did Sue read the last 2 days? So looking at the chart, she has days 1 through 5. I need to focus in on the last 2 days. Okay. Do you see what Miss Conley did? I'm focusing in on the last 2 days, day 4 and day 5. It says, how many pages did she read in those last 2 days? So it looks like I need to combine or add the 2 days that she read at the end of her reading. So day 4 and day 5. So if you look closely, it has 3 1/3 is what I'm saying, and 5 1/4. So I'm going to rewrite them on a separate sheet of paper over here so that you can see the combining. So let me show you what that looks like. Here it is. Remember when we're adding fractions, it's helpful for you to write them vertical, meaning up and down or on top of each other, so that you have all this space over here to work. Okay. Now, when we're combining fractions, the first thing you need to ask yourself, I was going to say each other, but we're at home by ourselves or with our family, is do they have like denominators? I see a 4 and a 3. I don't see like denominators. So that means Ms. Connolly is going to have to find the least common multiple. Remember, we did this yesterday between the 2 denominators. So I need to make an equivalent fraction, but I want my denominators to be the same. So my denominator is a 3 and a 4, and we've got to find a common multiple that they share. And we are going to look for the one that is the least. So remember, when we're finding multiples, we're skip counting. So 3, 6, 9, 12, 4, 8, 12, 16. Now I'm going to stop right there because I see that they share 12. Now, if you didn't, let's say you get to the bottom of your M and you have yet to find a common multiple, you must keep going, okay? But I found one, okay? So this means that I'm going to have to change my fraction to have a common denominator of 12. And I'm going to change 1/3 to have a common denominator of 12. Okay. Remember, we're making equivalent fractions. That means that we are not changing the value of 1/4. We are just representing it in a different way. So 1/4, let's go down to the 4. How many times do we multiply? 1, 2, 3. We multiplied 4 by 3 to get 12. So I'm going to multiply the numerator by 3. 1 times 3 is 3. And 1, 2, 3, 4. 3 times 4 is 12. So I'm going to multiply the numerator by 4. So it gets 4. All right. Remember, we didn't really do anything to our whole number. It's still there. So you can add it back in. And we'll bring 3 over. All right. Are you with me so far? Look at me. I changed the denominators. Okay. All right. Can I combine 4/12 and 3/12? Yes, they have a common denominator. So 4 plus 3 is 7. And 5 plus 3 is 8. Now, you need to always check to see if your fraction needs to be simplified. Is the numerator 1? No. Is the numerator 1 away from the denominator? No. Is the denominator prime? No. 12 is composite. So I would make you use your greatest common factor. So I'm going to look for factors of 7. I know 7 is prime, so I can only make it with 1 times 7. I know 12 is composite, so I can make it with 1 times 12, 2 times 6, and 3 times 4. Now I'm looking at factors here and factors here. The only common factor that they share is 1. If the only common factor that they share is 1, then it's simplified. So it looks like Sue read 8 and 7/12 of her pages in her book. I hope that was helpful, friends. You have done such good work. I am missing doing DMR with you at my small group table. Tomorrow I will be back to do Wednesday with you, and then we'll take a break for the weekend, and I'll be back soon, okay?